In preview activity 4.1, excuse me, we have a person who's walking along a straight path and walks at a constant rate of 3 miles per hour. Now what we're going to do is we're going to create a couple of graphs and look at the relationships between them. So on this left side, notice that we're plotting miles per hour versus hours. And since this person is going at a constant rate of 3 miles per hour, we could say v of t equals 3. Now if we were to plot that, right here this is our v-axis, this is our t-axis. So here's 3, and they're doing this for an undetermined amount of time. And our graph is the constant graph, so it's a horizontal graph. And there's our velocity graph. So now, moving on, we're going to talk about what's going on. For instance, how far has this person traveled after 2 hours? Well, if they're traveling at a rate of 3 miles per hour for 2 hours, and they're always going 3 miles per hour, then they're going to have gone 6 miles. Here's something that's interesting. If we cut off our velocity graph at 2 hours, notice what the area of this rectangle is. It's 2 by 3, so this rectangle has an area of 6 units. Now what did we do there? We multiplied 3 miles per hour times 2 hours. That area represents the distance traveled. This is going to be a really big finding as we move forward in this chapter. Now, if we wanted to come up with an algebraic formula that gave the position of this person as a function of time, well, we know they're going at constant velocity of 3 miles per hour, and let's go ahead and assume that s of 0 equals 0. In other words, they're starting at a distance of 0. Then our position function, s of t, is just a linear function. It has a slope of 3 times t plus a y-intercept of 0. So our position function is going to be just 3t. Notice the derivative, s prime of t, equals 3, which is v of t. So that relationship, that very powerful relationship we saw back in chapter 1, we still have. Now let's go ahead and graph our s of t on our other set of axes. So we know at 1 hour this person is going to be 3 miles. So just make sure, because our spacing is a little bit different. And at 2 hours they're going to be 6 miles. And so we have a linear function that starts at 0, 0 and increases. Now, if we wanted to know for what values of t is s increasing, well, we could certainly say s of t is increasing when t is greater than 0. Now why does this make sense? Well, when t is greater than 0, s prime of t is positive, or v of t is positive, which means we have an increasing, which means s of t is an increasing function because its derivative is positive.